Right, okay. Number 3 that I gave you before we went out, okay, it says the slope of the tangent is 6. The slope of the tangent to this curve is 6. So you know the slope is dy dx. So that means dy dx equals 6. So you know the answer. So here you differentiate. So differentiate here, what will I get? 2 minus 2x. Okay? So 2 minus 2x, and you know the answer is 6. So you put in something for x, and you came up with, you got the answer you got was 6. X is on one side, numbers on the other. So leave the minus 2x. The 6 is over here. The 2 comes over the wall, becomes a minus 2. So you get minus 2x equals 4. There's a minus 2 stuck to the x, so that means divide each side by minus 2. And you end up with x is equal to, plus divided by minus is minus 4 divided by 2 is 2. So x is minus 2. Right? So it said find the point. So you need to find a y term. So you get the y from the curve. Okay, so you have to go back up to find where y equals whatever. Okay? So everywhere I see an x, put in a minus 2. So y equals 8 times plus 2 times minus 2 minus 2 to be squared. Now make sure you put the minus 2 in brackets, girls, to put into the calculator, because if you don't, you get the wrong signs. Okay, so into the calculator with that, that would be 8 minus 4 is 4. 4 plus 4 is 8, I think. Right, that would be minus 4. That would be minus 4. Actually, it would be 0. Has anyone else done? Did you get 0? Yeah. Okay, so the point is minus 2, 0. Is that okay? Right. I'm moving on to the next section now as well, because we have 2 classes, so that means I'm going to get a bit of the next section done, because I haven't got a whole section done. I only did half of that. Right. So the next section, girls, is, it's new information, but there's no new methods, as in we're still going to be getting dy dx. Right. Okay. So what I'm going to be talking about is maximum and minimum turning points. So what's a turning point, girls, is, you know, if you have a curve and it's a smiley face, right? Down here, that's a turning point. It's basically the curve is coming down and it turns and it goes back up. Okay? Right? So here, if I have a curve that's a sad face, this is the turning point. Okay? So this is the turning point. It's where the curve was going up. So it's going up, 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 and it gets to this point and it turns and comes down. Okay, so it turns and goes back in the same direction again. Okay, if you have a cubic equation, girls, remember a cubic equation? They started low and finished high, or they started high and finished low. Remember a cubic equation? When we did functions, that's what they look like. Here, a cubic equation has 2 turning points. There's one up here, and there's one down here, right? And these are called turning points. Okay? And this one here has also 2 turning points. There's one here, and there's one here. It's coming down, it turns to go back up. It's going up, it turns to come back down. So these are called turning points. So that's what a turning point is. Obviously, girls, a line has no turning point. So a line has no turning point because a line just keeps going the same direction all the time. It goes up, 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 or it comes down, down, down. Right? It never turns. Right? So a line has no turning point. Okay? Is that alright? And a circle is just made up of turning points because it's constantly turning. Okay? Right? Okay, so turning points, are we okay? Right, okay. Now I want to distinguish between a maximum and a minimum. Maximum means it's up high, minimum means it's down low. Okay? So this one, is it up high or down low? Low. So this is a minimum turning point. Right? What about this one? It's maximum, it's up high, it's up at the top. So it's a maximum turning point. So if you have a happy face, it's always going to be, there's one turning point and it's always going to be a minimum. If you have a sad face, there's one turning point and it's always going to be a maximum. If you have a cubic equation, you have two turning points. As you can see, there's one here and one here, right? And the maximum is the one that's up high and the minimum is the one that's down low. So what's this one? Maximum. And this one is the minimum. Now we'll be learning how to figure out which one is the maximum and which one is the minimum, right? Not today, right? Okay, but we will have a method. For the moment, you're just going to imagine a diagram, okay? So this one is down low, so this one here would be the minimum, right? Okay, and this one up here is the maximum. Okay, so what we're going to do is we're going to learn in this section how to find the turning point number 1, and then how to figure it out whether it's a maximum or a minimum, right? Okay, so for the moment we'll be using the knowledge we have and we'll be saying whether it's a maximum or a minimum, but I'll give you a maths way to do it towards the end of this section. Okay, so we're going to find the turning points and then we're going to say whether it's a maximum or a minimum. Okay, right, so the rule for the turning points, girls, is, can I take that away? Right, at the turning point dy dx equals 0, okay, that is a rule that is not anywhere, so it has to be in your head, okay, so highlight it, put a box around it, whatever you do with your notes to show that this is something you need to learn off, right? Okay, so this isn't in the log tables anywhere and it's not going to jump into your head, right? Okay, and the steps to find turning point. A turning point. Number 1, find dy dx. Number 2, let whatever your dy dx is, dy dx equal to 0. So let it equal to 0 because that's the rule. At the turning points, dy dx equals 0 and then you solve for x. So let it number 3, get the matching y. Like we did a minute ago, you know, the way we solved for x and we found out what y is. So get the matching y, and then you'll have your curve xy, and then decide whether it's a max or a min. And as I say, we'll have a maths way to decide by the end of this section, but for the moment we're just going to imagine it in our heads. Max, decide whether it's a max or a min. That reads, or, sorry. Is that okay? Right, there are the steps. Find dy dx. Nothing new there. Let dy dx equal to 0. X is on one side, numbers on the other, and solve it. Right, you'll end up with x equals a number. Take that x equals a number, put it back into the curve to get your matching y, and then I'll show you how to decide whether it's a max or a min. Right? Okay, example 1. Is that down? No. Am I good? I'm okay? Right, example 1. Find the turning point, right, of the curve y equals that, and then decide whether it's a max or a min. Okay? So you see the words turning point and you say, I know the rule. The rule is that dy dx equals 0. And as I say, that's not going to jump into your head. You need to put it there, so you need to learn it. Okay? So dy dx equals 0. So then I can get dy dx. What is dy dx? 2x minus 2, isn't it? Right? And you want that equal to 0. Okay? So that's just an equation in x. So you want x's on one side, numbers on the other. So leave the 2x. The minus 2 comes over and becomes a plus 2. The 0 does matter. Okay? Are we all okay with that? And then there's a 2 stuck to the x, so that means divide each side by 2. And you'll figure out that x is equal to 1. So you have half the turning point now. Okay? So to get the other bit, the y value, you go right back up to the curve like we did in the previous section. So you go right back up to y equals x squared minus 2x minus 5. Everywhere I see an x, put in a 1. So y is equal to 1 squared minus 2 times 1 minus 5. So into the calculator with that, and that's 1 minus 2 is minus 1. I think you get minus 6. Okay? Is that alright? So the turning point, girls, is x is 1, y is minus 6. Right? And then it says, is it a maximum or a minimum? Right? All you have to say is, if I was to draw that, what shape would that be? Would it be smiley face or sad face? Smiley face. Why would it be a smiley face? Because the x squared term is positive. And if it's positive, you're smiling. Okay? You know, you wouldn't have to draw it at all. You wouldn't even have to draw what I just drew. Right? Okay? Because they expect you to know, so the fact that you know is grand. Right? So if we have a U-shaped graph, a smiley-shaped graph, is the turning point, is it a maximum or a minimum? It's a minimum. So that's enough for the moment. Okay? So all you have to do is write down it's a minimum, because it's a U-shaped graph. Okay? Are we okay with that? Right. Example 2? No? Yeah. Okay, I'll wait. Don't panic. No, it's minimum. Right. This curve has no maximum. Right? It has no maximum. It only has one turning point, and it's a minimum.
Before you even start the sum?
Yeah, before you even start the sum, you can tell it's a minimum. You don't know what it is, though. You still have to find out what it is.
Why wrote down like minimum? Would you say that somewhere?
Oh yeah, you would, yeah, because you've shown. What I would do is I would draw. Even if you hadn't a clue, I would say, oh, that's that, and it's a minimum, right? Okay, so I would even show them that I'm not guessing. I know what I'm doing, right? Okay, right? Is that all right? Can I go? Going.
Joe had the equation is x squared.
Yes.
Does that not mean that it's always going to be a minimum anyway?
Yes. Yeah. 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 That's what we just said. Yeah. Yeah. No, but that's grand. Knowing that, right, is you've kind of you know that before you start. Look at this one, right? Example 2. Come on, tell me before we start. Right, I haven't figured it out yet. When I get the point, is it going to be a maximum or a minimum? It's going to be a maximum, because this is going to be a sad face, isn't it? Because the x squared term is negative, and if it's negative, you're frowning, you're not smiling, so it's like this. So the turning point is going to be up here. So we know when we get the answer, it's going to be a maximum. Right? Is that okay? Because that's the only turning point there is. Right? So find the turning point. So you would say, oh, at the turning points, dy dx equals 0. That's the rule. Okay? So we get dy dx. So to get dy dx, we differentiate. So differentiating here, what will I get? 4 minus 2x, and you let that equal to 0. Okay? So differentiate 4, you get nothing. Differentiate 4x, you get 4. Differentiate minus x squared, you get minus 2x. X is on one side, numbers on the other. So 4 is moving, minus 2x stays put. The 4 comes over the wall and becomes a minus 4. There's a minus 2 stuck to the x, so that means divide each side by minus 2. And you end up with x is equal to A minus divided by a minus is a plus, 4 divided by 2 is 2. So x is equal to plus 2. So I need to find out what y is. So I get y from the curve, okay? So right back up to the start, and you get 4 plus 4x minus x squared. Okay, everywhere I see an x, put in a 2. So that's y equals 4 plus 4 times 2 minus 2 to be squared into the calculator with that, and you'll get 8. Right, okay. So your turning point is 2, x is 2, y is 8, and you've already told me it's a maximum because it's a sad face, and sad faces only have one turning point, and they're up at the top, so it's a maximum. Is that okay?
Yeah.
Right, okay. Time, okay. I'll stop recording. Okay.